Continuing with the power angle equation, in the last session we have derived the power angle equation for non-salient pole type of machine, and also we'll see the power angle characteristics of non-salient pole or cylindrical rotor type of machine. In this session, we'll look into the salient pole machine's power angle equation and its characteristics. Before drawing the vector diagram for salient pole machine, we know that the complex power, that is SG, is given by two component PG plus JQ, where PG is the active power, QG is the reactive power. That is, the active power is expressed as VI cos phi, whereas the reactive power is expressed VI sin phi in terms of volt amperes or K volt ampere reactive or kilovolt ampere reactive, whereas the active power VI cos phi, either it is expressed in terms of watts or a bigger unit of kilowatts. Okay, note that because I is defined positive out from the machine, because we are considering this as a generator, equation 1 defines PC and QZ positive in a generator sense. Okay, that is the concept of the sign convention for generator for active and reactive power. Note also the equation gives per phase values of a power, that is whatever were expressed here, Vi cos phi as active power and Vi sin phi is a reactive power for a per phase basis. Now, in the two reaction theory for a salient pole machines, the air gap is not uniform. Therefore, while representing the synchronous machine in the salient pole, because of non-uniformity of the air gap, then it is not represented with XS, but it is represented with XD and XQ, because the reactance possessing along the Q axis and the D axis has got different value because of non-uniformity of the air gap. Therefore, there is a concept of two reaction theory or two axis theory. Here we have got one is the D axis, the another one is Q axis. Then we note that here the generated voltage is always fall on the Q axis. Okay, we'll start with the drawing the vector diagram, taking into the terminal voltage, load current and the power factor. That is a V, you can take there is a arbitrarily the phasor of the V. Then I am considering here lagging power factor. Then I lags V by an angle of phi. Therefore, I drawn here the vector I lagging V, because I consider this vector diagram for lagging power factor. Now we know that to get the value of the generated voltage, in the case of non-salient pole type of machines, what you used to do is to the terminal voltage, if you are adding a resistive drop and the reactance drop, then what we are getting is the internal generated voltage. But in the two reaction theory, you are resolving this I into two components, that is ID and XD. One along the Q axis, the another along the D axis. Therefore, also you have got two reactances. One is XD, another one is XQ. Therefore, in this vector diagram, I am neglecting the resistance here. Therefore, to value of V, if you are adding two reactance drop, one is the drop due to the direct axis reactance, the another one is the drop due to quadrature axis reactance. If you are adding these two drop to the terminal voltage V, then what I am getting is E. Then what I am doing here is I am resolving I and V along the D and Q axis. Just you look into the here, this is the quadrature axis voltage VQ, whereas here it is the direct axis the voltage VD. Here V is resolved into two components. Similarly, I is also resolved into two components. One is the IQ along the Q axis, the another one is ID along the D axis. Now, to get the total generated voltage E, what I have to add is To the V, I will add IDXT, that is the drop due to the direct axis reactance. To that, I have to add the quadrature axis reactance drop, that is IQ and XQ. Just you have to look into here. To the V, what I am adding here is IDXT. You see the phasor of the IDXT, it should be perpendicular to ID. This is the phasor of the ID, therefore this IDXT should be perpendicular to this ID, then it has to add it to the V, because I am adding the different drops to the V so that I have to get the total generated voltage E. First drop is what I have added here is IDXT. The phase of this should be perpendicular to ID because it is a IDXT drop. To the tip of IDXT drop, what I have to add is IQXQ drop. To the tip of IDXT, I have to add IQXQ. That should be perpendicular to IQ. That should be perpendicular to IQ. So that I will adding here IQXQ. Then the total voltage what I am getting V plus IDXT plus IQXQ. That is a vector sum. What I am getting here is the total generated voltage E. That is the total generated voltage E. This is how we have to draw the vector diagram for the salient pole type of machine. From this vector diagram, you have to find out what is the power angle equation. Power angle equation. Just you have to look into this vector diagram and some of the identity I will write using this vector diagram. The angle between I and E I am defining as a B, and we know already the angle between V and E is called as the load angle or the torque angle, that is delta. That is angle between I and E is beta, angle between E and V is a delta, whereas between V and I it is a power factor angle phi. Okay, look into this. From the phasor diagram, I will redraw this in the next slide, and I will how to find out this I will tell you. That is what I am getting is it is V cos delta. V cos delta means what? This is V is resolved along the Q axis. That is a V cos delta. That is VQ is nothing but V cos delta. Then how to get the V cos delta? V cos delta. Then you look into the total here. From here to here it is E. In E, if we are deducting IDXT, that is nothing but this value. Therefore, what I am getting is V cos delta. That is V cos delta is equal to E minus IDXT, because this phasor is same as this, that is between this point to this point. Therefore, your value of V cos delta is E minus IDXT. Similarly, if you look into the D component of voltage, that is this D component of voltage, that is VD. VD is nothing but V sin delta. This is V sin delta. You can take the triangle of this. Take this triangle. In this triangle, the opposite side will be V sin delta. V sin delta is equal to IQXQ, because it is a V sin delta is same as IQXQ. Therefore, IQXQ is equal to V sin delta. Okay. Therefore, I am resolved VQ and VD from V. Then I am expressing in terms of E and IDXT and IQXQ. That is resolving VQ and VD from V from this triangle with angled delta is the triangle in which I am establishing the relation. Then I am finding out V cos delta and V sin delta in terms of E, IDXT and IQXQ. Now similarly I am resolving the I into two component. One is the quadrature axis current and the direct axis current, in which I have got IQ is equal to I cos beta. You can see you can take this triangle. Here this IQ is the adjacent side. Therefore I cos beta and ID is I sin beta. That is this opposite side to beta. That is I sin beta. This is how we have to find out the value of, and the angle relation, that is angle phi. This angle phi is the total angle is beta, this angle is delta, therefore phi is equal to beta minus delta. The same thing I am written. These are the four basic equation I have written, one for the power, the other for the Q axis and D axis voltages, and the another equation for current equations, and the third one is in the angle equation, voltage equation, current equation and angle equation. Okay, just you have to remove, just I am taking the only the voltage phasors here, V, ID, XT, IQ, XQ, this is VQ and E. This from this triangle, that is we know that is E minus IDXT. This E total value is from here to it is E. If we are detecting IDXT in this, that is IDXT, then what I am getting is VQ. The VQ is nothing but V cos delta. Therefore, V cos delta is equal to E minus IDXT. Just now I written in the last slide. Then similarly, this opposite side to the delta is your VD. VD is nothing but V sin delta. That is nothing but IQ XQ. Therefore, IQ XQ is V sin delta. Similarly, if you are taking the current, only I am extracting the current phasors from the main vector diagram. Here it is IQ, it is ID, this angle is beta. Therefore, IQ is I cos beta and ID is I sin beta. This is the current relation, this is the voltage relation. Then phi is equal to beta minus delta. Then we will prove we have to derive the power angle equation. That is, we know that phi is equal to beta minus delta. Already you are established the relation between beta, delta and phi. This is the equation. From the last equation, this equation, you can take the cos function on either side, it is a cos phi, then you have to apply cos beta minus delta, cos A minus B expression you have to apply here. What we are getting is cos beta, cos delta and sin beta, sin delta. Then what I am interested in the power equation, P is equal to Vi cos phi. I cos phi I want, therefore I am multiplying I cos phi on either side of this equation. This is I cos phi, and here also I multiplied I cos beta cos delta and I sin beta sin delta. We can recall here I cos beta I sin beta with a different color. Then I have to write, because it is I cos beta is nothing but IQ, I sin beta is nothing but our ID, and our active power is Vi cos phi. Therefore, I am putting the value of the I cos phi this from this equation. What V is the common, instead of I cos phi I am putting I q cos delta plus ID sin delta. Therefore, IQ cos delta ID sin delta. Therefore, because you have written all these things here, IQ XQ is V sin delta. Therefore, IQ is V sin delta by XQ. And also from the voltage equation, E minus ID XT is equal to V cos delta. Therefore, your ID will be EV cos delta by XT from this relation. This relations I am substituting here. Here previously I cos beta is nothing but your IQ, I sin beta is equal to ID, that is already established here. It is established here in the equation number 3. Okay. Then these values IQ and ID I am substituting here. IQ and ID I am substituting here, and what I am getting we will see here. That is IQ. Once again I am putting here IQ and ID I am written here. Just I am substituting here. Therefore, substituting the value of IQ and ID, this is the expression of what I am getting here. That is V is common as it is. Instead of IQ I am putting V sin delta XQ into cos delta as it is. Similarly, ID is replaced by E minus V cos delta by XT, and sin delta is as it is. Just regrouping the things, then what I am getting, multiplying this V to the both the terms, what I am getting is V square sin delta cos delta divided by XS, and V is also multiplied to E, and I am bifurcating this second term. It is E by XT into sin delta, EV by XS into sin delta, and it is a minus sign, V square, that is V into V square divided by XT, sin delta and the cos delta, sin delta and cos delta. This is a equation what I am getting here. Further, I am regrouping the things, that is taking EV by XT sin delta first, then V square sin delta by XQ, V square minus V square by XT sin delta cos delta. Here in the both the terms, sin delta, cos delta v square is a common. That I am taking common. That is first term I am keeping as it is. In the second term I am taking v square sin delta cos delta common. Then what is left out in the bracket is 1 by h cube minus 1 by xt. Then this is EV by xd sin delta, v square sin delta cos delta. Sin delta cos delta can be written as sin 2 delta by 2. Sin delta cos delta can be written as sin 2 delta by 2. Therefore, I am replacing the sin 2 delta by 2. This v square is as it is. Then it is 1 by x cube minus 1 by xt. It is a bad surface. This is a power angle equation of the alternator in the salient pole type. In the salient pole type, this is the same thing is written here. It is per phase value. Okay. Then if the value of xd and xq are equal, that is in the case of non-salient pole type, that is nothing but xs, then this equation is reduced to once again EV by xs sin delta. Then if you are drawing the power angle characteristics for this particular machine, then we have got a power angle equation. It is already derived here. That is EV by xt sin delta, v square by 2, 1 by xq minus 1 by xt sin 2 delta. Just you have to, on x-axis you have to take delta and y-axis p. Then here there are two terms and you have to draw two different curves and you have to superimpose one another, then you are getting the total power p. Therefore, it is the first term, that is EV by xd sin delta. It is or like the sine function, therefore it is a sine function you are getting. Second is also sine function, but it has got the double the frequency of the first one. Therefore, the second term has got the two waveform, two half cycles. I got two half cycles here. Then this is the second term. That term is called as a reluctance power here. If you are adding these two curves, if you are adding these two, you have to superimpose, then what I am getting the total power P. This is a total P delta. You can observe here the maximum power occurs, it is less than 90 degree because of its it is a salient pole because non-uniformity of the air gap, that is the maximum power occurring less than when this angle delta is less than 90 degree. Okay, that is P max. This is how we have to derive the power angle equation for the salient pole type of machine.